So in the last video, we introduced the first of 4 intermolecular forces in this chapter. We introduced this concept of dispersion forces. It's the weakest of the intermolecular forces. All molecules experience dispersion forces, and dispersion forces are due to the presence of temporary dipoles that exist in an atom or molecule due to the movement of electrons in the electron cloud or the orbital of that species. So dispersion forces, all molecules have them. They are the weakest intermolecular force. We can use dispersion forces along with the size or the molar mass of a substance to say something about the properties of a substance as well as the magnitude or the size of the dispersion force in similar molecules. So I have a list here of noble gases. These guys are in group 8 of the periodic table, along with their molar masses and their boiling point, the temperature it takes for that substance to go from the liquid to the gaseous phase. So since we said all molecules have dispersion forces, we know that all of these guys have dispersion forces. But can I say something about which one would have the greatest or strongest dispersion force? And so remembering that dispersion force is due to the movement of electrons in the orbital or the electron cloud of the species, you can easily envision that the larger your molecule or atom is, the more electrons you have. You have a larger electron cloud, therefore you will generate a larger dipole in that species due to the presence of more electrons. So the bigger your molecule is, the higher the molar mass, you would expect to have the stronger the dispersion force. And that also makes sense when looking at these boiling points too, right? Looking at these boiling points, it takes more heat to get xenon in the gaseous phase than krypton. That's because xenon has greater dispersion forces that must be overcome to get that species to the boiling point. So the take-home message from this is when comparing molecules within a family, like noble gases, or group, like halogens or chalcogens, when comparing molecules of similar groups, dispersion forces increase with increasing molar mass. So for example, if I was to ask you between chlorine and bromine, those are two halogens in group 7. Between those two, which would have the greater dispersion force? You would say bromine. Bromine has a bigger molar mass than chlorine. And so you would also expect bromine to have the higher boiling point as well. So dispersion forces can help us say something about the properties of a substance, particularly boiling point, in conjunction with its molar mass.